All right, everyone. Here are the review problems for the Chapter 7 Similarity Notes review. So, a large part of this chapter was based on ratios and similarities. Ratios are fundamentally a relationship between two quantities, A and B, can be read as A to B, A colon B, and A over B. As long as we keep the corresponding values consistent, we can make ratios out of almost anything. So we're going to solve these problems here. 7 over x is equal to 14 over 9. Well, the way that we would solve it is by cross multiplication. 7 times 9 is 63. 14 times x is 14x. Divide both sides by 14 to isolate that variable. And we end up with x being equal to 9 over 2, or 4.5. We're going to do something similar in number 2. X minus 3 over 4 is equal to x plus 9 over 3. We're going to cross multiply. So we'll have 6x minus 9 is equal to 4x plus 36. I'm going to add 9 to both sides to give me 6x is equal to 45 plus 4x. Now I'm going to subtract 4x from both sides to give me 2x is equal to 45. Divide both sides by 2. X is equal to 45 over 2, which is the same as 22.5. Number 3, similar polygons. Two triangles are similar. Find the value of x. So, we have triangle GVC is similar to MBH. Note the order matters. G and M are congruent, V and B are congruent, C and H are congruent. Therefore, these triangles are similar by angle, similarity. We want to find the measure of x, so we're going to set up a proportion such that 12 over x is equal to 16 over 22. We'll do our cross multiplication such that 12 times 22 is 264, which is going to be equal to 16x. Divide both sides by 16, and we get x is equal to 16.5. Parallel proportional parts, notes to look over about the relationships of parallel lines and parts and ratios. Mid-segment, big thing here is that the mid-segment is half the length of the bottom base, because the mid-segment is basically the connecting point between two midpoints. Parallel lines, we get a set of 3 parallel lines. We can make a set of relationships of ratios. 2 triangles are similar when the following parts are proportional. Altitudes, medians, and angle bisectors all help us determine proportionality. Question 4, we want to solve for x. We have 2 triangles here. We've got this triangle here. We've got this larger triangle here. So I can set up my ratio a few different ways. The way I'm going to do it is the ratio of x over 12, that is to say the sides of this purple triangle must be equal to the ratio for this orange triangle. Note that the orange triangle partially includes the purple triangle. So x over 12 must be equal to 4 plus x over 17. Because 4 plus x is 4 plus x, 5 plus 12 is 17. At this point, cross multiply again, and we get 48 plus 12x is equal to 17x, because 4 times 12, and 12 times x. I'm going to subtract 12x from both sides to give me 48 is equal to 5x. Divide both sides by 5, so 48 divided by 5, I get 9.6 is equal to x. Number 5, x equals something. I've got two triangles here. I know that this side is the same as that side, so this here is also 16. We know that I have angle bisectors, meaning that this triangle is similar to that triangle, which then means I can make a ratio such that 16 over 21 must be equal to 2x plus 6 over 16. Basically, I'm looking at the sides that are opposite the bisected angles to determine my order. Solve this out. Well, 16 times 16 is going to be 256 is going to be equal to 42x plus 6 times 21, or 126. Subtract 126 from both sides. So 256 minus 126, 130 is equal to 42x. Divide both sides by 42. X is going to be approximately 3.1. It comes out to 3.095238 repeating further down the line. But we're going to round that off to 3.1. Last one, word problem. 5-foot tall student casts a 3-foot shadow. The tree next to her casts a 45-foot shadow. What is the height of the tree? So we've got ourselves a pair of similar triangles. We got the triangle formed by the 5-foot tall student, 5-foot tall, 3-foot shadow. And we got the tree next to her that casts a 45-foot shadow, and we want to find x. So we're going to set up our ratio such that 5 over 3 is equal to x over 45. And bear in mind, there are a number of ways we can set up these ratios. These are just the ways that I'm solving them. So 5 times 45 is equal to 225. So 225 is equal to 3x. Divide both sides by 3. X is equal to 75. So how tall is a tree? 75 feet. And that, folks, are the note review problems for Chapter 7. As always, please ask if you have questions.